Hey guys, I know you are super excited to be reviewing for your finals, so I'm gonna hit you with some videos. Let's start with number one. So, what is the 10th term of this sequence that we are working with right here? Let me change my color here. What's the 10th term? Well, here is the first term, second term, third, fourth, fifth. So we're looking for 6th, 7th, 8th, 9th, 10th, right? So let's find the pattern. Hopefully you can see, sometimes it's easier to start from here. 1 times 5 is 5, 5 times 5 is 25, 25 times 5 is 125, and 0.2 times 5 is also 1. So it looks like we are just multiplying by, we're multiplying by 5 each time. So this is a geometric sequence, right? And if we want the 10th, let's see, we have 125 times 5. So that's going to be the 6th times 5, 7th, 8th, 9th, 10th. 390625. The answer is B. All right, what's next? 2. Samantha invests $400 in a bank account that earns 10% annual interest compounded monthly. Each month afterwards, she puts in $50 into the account. Choose the recursive formula that models the value of Samantha's investment. So our starting value, remember this is a geometric sequence which kind of matches to an exponential relationship. So our starting value was 400, that's going to be our u sub 0. So let's see if we can do any, cross out anything here. My words are escaping me. U sub 0 equals 400, so it could possibly be A. U sub 0 equals 50. It's not going, elimination. That's what I'm thinking of, elimination. So it looks like it could be A, C, or D. We have eliminated B because the starting value is not 400 in the bank. We're earning 10% annual interest compounded monthly. Okay, this compounded monthly means we're going to take the interest that is being raised and divide it by 12 because 10% is the annual interest. If we're compounding it monthly, we have to take that 10% divided by 12. So we've eliminated A. We know it's going to be either C or D. Okay, and then also, we don't even have to do any math here. Also, we know that she puts $50 into the account each month. So it has to be D because it says we're adding 50 each month. Okay? All right, here. Whoops. 2, 3. Gloria had some money in a jar and decided to put $15 each month into the jar. Okay, so if she's adding $15 each month, I've eliminated B, right? There we're multiplying $15. And after 1 year, she counted the money in her jar and she had a total of $320. Choose a recursive formula to model this scenario. So $320, I guess we need to figure out what our starting value was, right? So after 1 year, after 12 months, we're going to kind of work backwards. If this is our months and these are our dollars, if 12 months she had $320, right? Oops, $320, and she was putting in $15 a month into the jar, then the month before she would have had $15 less than that. So she would have had $305, right? And then a month later, 10, she would have had $15 less than this, so she would have had $290. Okay, so let's use our calculadora. If we have 320 and we subtract 15, so that's 11 months minus 15. That's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So she started with $140. So, and since we've already crossed out B, the answer must be C. Sorry, I know that it might get annoying because I have the sniffles. It's my allergies or something. I'll try not to do that, you guys. Question 4. Question 4. Oh, this is this is the PDF version that does not have questions 4, 5, 6, 7, and 8. So I will have to get those and hit you guys later. But let's go to question number 9. Which ordered pair is a solution to the systems of equations? So let's go ahead and use our calculator for this one. For the systems of equations, if we have 2, we're trying to figure out where they intersect. The easiest thing to do is to put both of those into the y equals. They're already y equals something, right? So let me clear out what I have in here. We will put, actually, it might be faster for me to just do this by hand, but for you guys, I'll show you how to do the calculator. So x squared minus 3x plus 3. X squared minus 3x plus 3. And 3x minus 6. The solution to the systems of equations is where they cross. So 3x minus 6. And I think a zoom 6 will do this, our basic negative 10 to 10, negative 10 to 10. There's the parabola. The first one, cool. There is the linear one. And here's a trick for you guys. If you trace, where's my dude? Where's my little guy? Trace. Ah, there he is. If you trace over to where you think they're intersecting and then you hit zoom in, you can get a little better idea. You have to hit enter a couple times about what exactly it looks like where they intersect. So it looks like the intersection is going to be really close to right here. And in order to find the exact number, we do second calc, intersect, enter. And then you got to hit enter a couple times. I don't know why that didn't work. Let me go out. Maybe I just couldn't see it. So again, second calc, intersect. Yeah, first curve, second curve. I guess I won't do that when you're zoomed in. Good to know. So it looks like they intersect where x is 3 and y is 3. And the calculator, sometimes you guys will give you really long decimals like that. And you just have to realize that's the calculator's way of saying 3. Because I bet if we did it by hand, that it would, it would give you the same thing. And to do it by hand, you would just set them equal to each other. So x squared minus 3x plus 3 equals 3x minus 6. We need to get everything. This is a quadratic, right? So I know it's not going to be as simple as just getting everything to one side. But we do need to get everything one side and get the other side equal to 0 in order to solve a quadratic. So I'm subtracting 3x's, I'm adding 6's. This side is 0. You've got to do the same to the other side, but you can only do it to like terms plus 6. So what that is x squared minus 6x, if I combine those two x's, plus 9. And I bet you guys that this is factorable, because two numbers that add up to be negative 6 and multiply together to be positive 9 are negative 3 and negative 3. So x minus 3 times x minus 3. There's only one x answer, and that is x equals positive 3. Right? Positive 3. And then to get the y value of that point, you just put this into, and I would just choose the easiest other equation. So that's here, y equals 3x minus 3. So that's 3 times x. So that's really 3 times 3, which is 9, minus 6, which gives us y is 3 also. So that leads us to question number 10, which is a quadratic. But what it's asking us to do is match it to the equation which is the same. So obviously you're looking at this saying to yourself, oh, if I complete the square, I can turn it into vertex mode, which is what I'm looking at, or vertex form, which is true. Or you could also put this equation into your y equals and all of the other equations into your y equals and see which ones are exactly the same. So either way works. I've seen you guys do it both ways. I don't know what's quicker for you, but let's just as a review for completing the square, let's do that. So completing the square, I have x squared minus 4x, and I'm going to keep this in parentheses. Okay, and then I'm going to put minus 77 outside of the parentheses. I'm going to take half of negative 4, which is negative 2 squared, which is positive 4. So I'm adding 4 here. Now this is a little bit different the way I'm doing it, you guys, because normally I would throw that negative 77 on the other side and call it positive 77. But since I don't need to like solve this equation, I'm going to keep it all on one side, which means if I add 4 to this side, instead of adding 4 to both sides, if I had done that to get it back over to the other side, I would have to subtract 4 again, right? So if I just subtract 4 over here, I should be able to get my answer. And this way, if I'm adding 4 and I'm subtracting 4 on the same side, I'm technically not making any change. 0 is happening, right? Positive 4 and negative 4 together is 0. 0 change is happening. So negative 77 minus 4 would be negative 81 on the outside. And then this factors into x minus 2 squared. So that's how you do it the long way. And it looks like that answer is going to be B. And on this video, I probably have enough time to do this next one. I just have to multiply 5 minus 6i, negative 2 plus 4i. So I'm just going to do the area model here, you guys. It's the easiest way I feel like to multiply two binomials together, although hopefully when you guys get good, you should be able to do this in your head. If you want to learn how to do that, I'll do it. I think foiling helps do that. But here, just so you have an idea of what we're doing, we'll do 5 minus 6i, and on this side we have negative 2 plus 4i. And it's going to help us to remember that I is actually equal to the square root of negative 1, which is an imaginary number. But what that means is we never really use I, but I squared is just negative 1, and that's going to come in handy here. So let's fill out our area model. 5 times negative 2 is negative 10. Negative 2 times negative 6 is positive 12i. 4 times 4i times 5 is positive 20i. And negative 6 times positive 4 is negative 24. And then they both have an I, so that's I squared. So what that means is negative 24i squared, and this is important, is really negative 24 times negative 1, which is positive 24. So now when I combine my like terms, 24 is just a number, and I combine it with negative 10, and my i's, I can combine them separately, and I'm going to combine that positive 12i and positive 20i. So when I do that, 24 minus 10 is just 14, and 20 and 12 is plus 32i. So that is D.